Welcome back, Neutron Tech crew. Today's build follows Dmitry Lukin, one of the best in the business, as he takes on a full house construction from the ground up. Everything kicks off with solid site prep, leveling out a wide, compacted sand base that sets the stage for the entire structure. Right away, before anything else goes down, Dmitry gets the sewer piping network buried into that sand. Timing is everything here. Those pipes need to be locked into place before any insulation layers or slab components even enter the picture. It's only once that underground plumbing is fully set and stable that he moves on to building up the thermal foundation system. Around the outer edges of the slab footprint, he puts together insulated permanent formwork panels that act as a solid, rigid frame. At this stage, the buried sewer lines are already secured in the sand, and the perimeter now forms what's essentially an insulated tub ready to hold the slab. Attention shifts to the insulation layer next, where Dmitry carefully lays XPS tectonical boards across the entire footprint, making sure every seam is tight and aligned. Vertical pipe exits and conduits push up through the insulation at specific points, all tied to the underfloor heating layout. These placements mark exactly where the future boiler room and technical zones will tap into the home's main systems. Hot and cold water supply lines are run so they surface precisely at the locations where fixtures and equipment will eventually sit. Planning the routing this way pays off down the line. It means fewer channels cut into walls, structural masonry stays solid, and unnecessary holes through finished surfaces are avoided entirely. Long coils of red pipe get unrolled across the slab area, with each loop carefully arranged in a deliberate pattern over the insulation. A grid of supports and ties locks every section of pipe firmly in place, so nothing shifts when the concrete is poured. As those heating loops spread out across the full slab, Dmitry ties the heating system directly into the overall reinforcement plan. The steel mesh gets opened up and arranged into its final working position, ready to do its job. Steel bars and mesh sheets are layered so they overlap properly, then tied together into one unbroken grid across the slab. Concrete naturally shrinks during curing and shifts with temperature swings throughout the year. In a heated Swedish slab, though, that movement becomes even more significant because of the constant thermal load from the radiant system underneath. With the reinforcement fully locked down, Dmitry moves to the mechanical heart of the slab, the collector manifold. Every heating loop needs a specific length and consistent flow resistance, so warmth spreads evenly across the entire surface. While that's coming together, Dmitry also starts preparing for the concrete finishing stage, dialing in the conditions needed for precise, flat geometry. From there, he completes the full Swedish foundation by constructing the insulated blind area that wraps around the house perimeter. This outer treatment is one of the most critical details. It carries the thermal protection and drainage strategy beyond the slab edge itself. Now that the foundation is done and sealed, the structure starts climbing above the surface. Dmitry chooses aerated concrete blocks, sometimes called AAC or gas concrete, for the first floor walls. It's a material you'll see all over modern Eastern European home building, and for good reason. Compared to traditional brick or solid concrete block, it weighs considerably less, which means the foundation doesn't have to work as hard. That said, aerated concrete has its conditions. It works best when weight is spread evenly across it and when tensile forces are managed with proper reinforcement. Dmitry taps each block into the mortar by hand with a mallet, making sure every surface sits flush, with no gaps underneath. Those gaps matter more than you'd think. They turn into stress concentration points. Rather than the load flowing smoothly across the block, it piles up at whatever edges are actually touching, and that's where cracks begin. So what he's doing here reflects solid masonry principles. A continuous bearing surface matters far more than laying speed. With the wall lines and openings mapped out, Dmitry works through each course in a steady, controlled sequence. You'll notice reinforcement starts showing up as the top of the wall takes shape, and that's not decorative. It's there to create a proper handoff between the masonry and the reinforced ring beam coming next. For that beam to do its job, it can't just sit on top of the wall like a hat. It needs to be mechanically locked into the structure below. That's exactly why reinforcement bars are set and aligned right at the wall head, acting as the continuity link between the two systems. As the walls lock in the building's perimeter and interior layout, Dmitry turns his attention to extending the livable space with a terrace. The challenge here is real. That terrace has to handle seasonal ground movement and freeze-thaw cycles on its own, without pushing any of those forces back into the main house. His solution is to build it as an independent load-bearing timber frame sitting on its own piles. Notice that he doesn't pour a single continuous slab connected to the house, and that's a deliberate choice. A rigid connection like that would act as both a thermal bridge and a frost lever, potentially transmitting damaging forces straight into the foundation. Using mechanical fasteners, Dmitry drills and secures the board to fixing points already prepared in the foundation. Once the aerated concrete walls hit their planned height, a critical new element enters the picture: large section timber beams, 145 by 195 millimeters, go in as the primary load carriers. Alongside them, secondary boards at 45 by 195 millimeters fill in the framing between. Each layer has a distinct role. The primary beams set the span and overall stiffness, while the secondary joists manage spacing and keep the deck from flexing under load. With the beam grid complete, 18mm OSB panels close off the deck surface. From here, the interior needs to be made ready for mechanical systems and future finishes. Dmitry starts prepping the aerated concrete walls so they can house wiring and plumbing cleanly and permanently. A grinder and cutting tools let him carve precise channels and recesses directly into the block face. Once the fittings drop into place, the pipes sit flush within the wall, leaving the surface ready to be brought back to a smooth, stable plane for finishing later. Aerated concrete pulls in moisture like almost nothing else, which means surface chemistry matters every bit as much as the physical prep work. Skipping the primer isn't an option here. It locks down absorption, settles any loose dust, and gives bonding compounds the right conditions to cure properly. With the walls fully prepped on a technical level, the project shifts into finishing, still demanding, just in a different way. Dmitry starts applying AMK, a wall cladding product made in Russia, where every individual brick is formed from real marble chip material. What makes this system stand out is how it replicates the look of brickwork while actually performing as a bonded composite surface. Adhesive fills and secures the joints, and the brick modules build up a convincing stone-like appearance. You can do. A protective film covers each brick during installation, and it only comes off after everything has fully cured. Up on the second story, once the main beams are locked into position, the builder moves on to fitting the internal members of the framing system. Joists go in at consistent intervals, forming that repeating ladder pattern that becomes the structural backbone of the upper floor. As soon as the deck feels solid, attention turns to building and raising the large wooden wall frames that shape the second story. Lumber gets assembled into full-height panels on the ground, with studs and openings already built right in. Essentially, each one is engineered to go up as a single prefabricated unit. This approach works so well because it dramatically cuts down on mistakes. Rather than stacking things vertically piece by piece, the builder can square everything up while the frame is still lying flat, then hoist it into place. Once that first wall goes up, the whole process turns into a careful, coordinated rhythm. One person holds it steady while the other drives the panel upright, rotating it from flat to vertical like a massive hinged slab. Temporary bracing goes on immediately so nothing can drift, because at this stage, every standing frame catches wind like a sail. With the first wall secured, The remaining frames follow one after another, each locking into the platform and lining up flush with the edges of the floor deck. What you're watching is the second story coming to life, not through cosmetic touches or finishing details, but through careful, deliberate construction. Starting the roof means establishing its geometry first, setting the long angled rafters that define the slope on each side. From a structural standpoint, this turns the roof into something that resists deformation, functioning as a bracing element just as much as a protective covering. Rafters go in at regular intervals, creating a rhythmic skeletal framework that channels loads downward into the wall plates beneath. None of that spacing is random. It governs how stiff the roof is and keeps the decking from sagging under the weight of heavy snow. Once the rafters are set, the next move is closing up the roof structure with a continuous deck surface. Instead of relying on OSB by itself, Dmitry lays long timber boards across the rafters to form a solid wooden roof skin. After the membrane goes down, he turns his attention to cleaning up the roof edges, particularly around the overhang zones. Large, rigid insulation boards then get placed directly over the sloped plane, laid out in wide, unbroken fields. The goal here is to create a thermal shell that wraps over the top of the building without any breaks. Panels go down in a staggered layout, which keeps the seams from lining up and eliminates gaps where air could sneak through. At the ridge, where two boards come together, he fills the joint with expanding foam, essentially fusing everything into one sealed, airtight surface. With the batten framework finished, the roof is ready to be closed up, and he starts laying OSB sheets across the entire roof plane. Every sheet gets positioned and secured so it spans across several battens, which turns the whole roof into one rigid structural panel. Large OSB sections go up efficiently, and Dmitry trims around any openings that get in the way. The roof window is one of the most critical interruptions on that surface, and it's exactly where careful precision becomes non-negotiable. Before any waterproofing goes on, Dmitry gets the skylight unit itself fully prepped and ready. After the window is set into its prepared opening, Dmitry secures it firmly in place. Large blue waterproofing membranes get rolled out over the OSB, pulled uphill along the slope, and pressed down smooth. Every sheet laps over the one below it, forming a layered drainage sequence so water always flows onto the next surface beneath. That same layering process then gets carried out on the opposite side of the roof. It sounds straightforward, but a pitched roof only does its job when both sides function as a single, unbroken protective system. Dmitry makes sure the roof is symmetrical, not just in its shape, but in how well each side actually performs. There's still a long list of work ahead to finish things off, particularly around the roof's perimeter. His main focus lands on the eaves, because that's the exact line where gravity, water runoff, and wind uplift all meet at once. None of this is decorative. If the eaves aren't rigid and perfectly straight, the entire roofing surface will buckle and wave. A black bituminous strip gets laid along critical lines, especially at joints, edges, and transition points. He trowels on roofing mastic and presses the strip into it, forming a durable, water-resistant seal. After that, the final layer goes on, asphalt shingles installed in clean, even rows. He begins at the bottom edge and works his way up in a steady, methodical pattern. At every level, the upper row has to overlap the one below it, so water always drops onto a lower surface and never finds a seam. Dmitry lines up each shingle to keep the pattern running straight across the slope, then locks them down with a nail gun. Wind attacks roofing the way you'd pull a zipper, and the only thing stopping it is the right number of fasteners in the right positions with the right overlap. As the shingle field climbs higher, Dmitry reaches the roof window again, carefully trimming and shaping the bitumen shingles around it. This part takes time because there's no room for shortcuts. Shingles need clean cuts and secure fastening without cracking. The core engineering principle at work is that this roof functions as a multi-layer system designed to drain and protect simultaneously. In climates where snow lingers for weeks and rainstorms hit fast and hard, you have to assume water will always be looking for a way in. Dmitry's approach builds in redundancy, so even when the outer layer takes a beating, secondary layers underneath keep redirecting water safely outward. When it comes to handling snow, shingles work so well because their surface naturally grips and breaks up the slide into smaller sections. Still, a roof can only do its job if the edges handle drainage properly, which is why Dmitry mounts the gutter system using metal hooks at consistent, close intervals. That spacing isn't about looks, it's structural. Heavy water flow and the weight of soaked debris will drag a gutter down if the support isn't there. Once a gutter sags, it pools water. Pooled water freezes, and frozen buildup starts tearing things apart. So the gutter is designed to catch everything coming off the roof plane and push it well away from the walls. Wooden surfaces and roof overhangs don't fail because rain hits them once. They fail from getting wet over and over again. Uncontrolled runoff soaks into fascia boards, discolors the cladding, and slowly opens the door to rot that only gets worse with time. With the roof drainage now handled, Dmitry turns his attention to the second story, where the open gable zone needs to be sealed and protected. First, a broad white protective membrane gets pulled tight across the entire exposed facade area. From there, he moves into the permanent thermal seal by fitting rigid beige insulation panels vertically against the gable wall. One by one, each board is raised, positioned, and pressed firmly into place, steadily covering the surface in overlapping sections. As the insulation climbs toward the roofline, Dmitry takes extra care fitting panels into the trickiest junction of the whole structure. Meanwhile, any exposed timber sitting beneath the roof overhang gets a coat of protective treatment. By this stage, the balconies already exist as raw structural platforms extending out from the building envelope. But there's a real difference between a platform that's standing and a balcony that actually works. Dmitry builds the frame from heavy boards and joists running perpendicular to the facade, forming the load-bearing skeleton underneath. What matters most here is that the balcony isn't treated like some bolt-on porch. It has to be locked into the structure solidly enough to handle real, shifting weight. Across the entire balcony surface, Dmitry lays down a continuous waterproofing layer, sealing it the same way you'd seal a roof. That membrane needs to travel up the wall connection and finish cleanly at the outer edge, so water has no path back underneath. This single detail is what separates a balcony that holds up for decades from one that falls apart after 2 winters. Now, it's worth stepping back and understanding why this project carries so much weight, because this is far from an ordinary build. Dmitry Lukin isn't just putting up a house. He's constructing a lasting answer to a question most people never truly figure out. What does a life shaped entirely by your own hands actually look like? We live in a time where housing often gets reduced to quick transactions, cookie-cutter layouts, and fixes that barely outlast the mortgage paperwork. Dmitry's dream house stands apart because it becomes something more than a structure. It's a physical statement about what he believes in. Every part of it reflects planning, discipline, and the willingness to pour time into something that won't pay off overnight. Nothing about this project relies on cutting corners, and that's exactly what gives it meaning. His approach reveals a builder who genuinely understands that real comfort isn't something you buy. It's something you engineer from the ground up. At its core, this project resonates because it's a human story wrapped inside engineering, and you almost never get both at once. Most dream house content leans heavily into fantasy. You're shown massive rooms, gorgeous finishes, sweeping camera moves, and the comfortable illusion that a home just materializes when enough money meets enough inspiration. Dmitry's story, though, runs in the completely opposite direction. His dream isn't expressed through excess. It's expressed through doing things correctly. Every step follows a logical order, done for the right reasons, even when no one will ever lay eyes on the work once the walls close up. Yet what people will notice is one of the most visually impressive and budget-friendly techniques out there, something Dmitry has put a real spotlight on. Just like before, he's executing a facade finishing method that gives the appearance of precisely laid brick masonry. The difference, as we've already explained, is that he achieves this without spending on real facing brick, clinker, or a full decorative masonry installation. After the lines are set, he shifts to the corner, because corners are where visual mistakes show up the loudest. Dmitry takes real care to carry the joint lines around the edge, so the brickwork looks like it naturally wraps the corner. And the reason this technique is both beautiful and affordable comes down to something straightforward. What he's really doing is producing an architectural facade effect through skill rather than expensive materials. In practice, this brick effect finish gives the house the visual weight and prestige of real masonry, without the price tag or the labor that comes with actual brickwork. Up on the second story, wood introduces warmth and rhythm, with horizontal boards that visually stretch the facade outward. It also turns craftsmanship into something you can actually see. Every board's alignment, every fastener, every finished edge, that's the builder's hand on full display. And the real aesthetic power here lives in how these two finishes play off each other. Brick effect render, on its own, can start to feel very uniform and flat when it covers everything. Timber alone, on the other hand, might push the whole look too far into cabin territory. Together, though, Dmitry makes the house gain contrast and a clear visual hierarchy. The brick finish anchors the lower portion with a solid, grounded character, while the timber lifts the upper section with a lighter, more textured feel. What you end up with is a facade that reads as both engineered and inviting. Even the color choices are intentional. Dmitry uses dark stained wood set against the lighter wall surface below. That contrast, as you can clearly see, creates a strong framing effect around every opening and edge. The wood starts functioning almost like a graphic border, an outline that makes the structure look more architectural and less like an unfinished site. On a deeper level, this pairing also tells a story. The brick effect stands for economic intelligence, a beautiful illusion that keeps money in your pocket. The timber cladding, meanwhile, stands for craft and identity, a material that demands patience, careful alignment, and genuine pride. By this stage, the facade already carries a strong personality through the interplay between the visually mineral surface and the natural wood. Refining the openings with that same timber gives the house real continuity because wood becomes the common thread tying everything together. This detail matters more than people realize. Facades often fall apart visually when they look like separate systems just stacked on top of each other. Here, though, the wooden trims serve as the connector that makes the entire building read as one coherent object. They become intentional accents that visually anchor the structure, and at the same time, they introduce a third plane of depth. Start with the main wall plane, then add the cladding plane, and finish with the trim plane. That kind of layered depth is exactly what separates a modern facade from everything else. It's what makes it look high-end and intentionally designed. Shadow lines appear, edges get sharper, and the whole geometry reads as precise the moment you look at it. This approach works even better when you pair it with textured or patterned wall finishes. Those surfaces, as beautiful as they are, naturally take the crispness away from your corners. A brick effect finish can absolutely look stunning, but without careful transitions, it tends to blur the edges around openings. Wooden trim steps in and fixes that. It outlines each opening with sharp, decisive lines and brings order back to the entire facade. The contrast between a lighter wall and the deeper tone of stained wood pushes that effect even further. So the trims and wooden accents here aren't just decorative elements sitting on the surface. What they actually do is correct how your eye reads the wall, because each frame around an opening works like a picture frame. It tells you exactly where to look first. Rather than getting lost in a busy or uneven texture, your attention follows the strong wooden border. On top of the visual benefit, though, this is a genuinely smart technical decision. Openings are where a facade is most exposed, because that's where moisture, material changes, and wear all converge in one spot. Refining those edges with timber gives Dmitry a protective layer that guards the surface against impact and gradual erosion over the years. Timber is also forgiving enough to hide small tolerance gaps, which matters because real-world construction is never perfectly precise. At its core, using the same wooden material around every opening goes beyond style. It's a statement about how seriously the work is being done. Dmitry is building a house that communicates intention through its smallest details. The home starts to carry the same qualities that have defined this entire project. Every edge breathes with the same patience and care that's been present throughout the whole building process. What you're seeing now is a deliberate refusal to leave any transition unfinished. Carrying that timber language across the second story and into the openings ties the architecture together into one unified expression. This is precisely how a dream house stops being just a structure. It becomes something personal, an identity, because the builder's discipline shows up in the finest edges. The entire building rises visually, and at the same time, the most failure-prone parts of the facade gain real, lasting protection. As the final images come together and the results speak for themselves, Dmitry might genuinely wonder if he's still dreaming. Honestly, this is the kind of dream very few people would ever want to wake up from. If you enjoyed this video, make sure to check out Dmitry's channel. He's one of the best builders you'll find anywhere on the internet.